Okay, I welcome you again to the UNU-INWEH Science Talk in this 30th anniversary year. I am your host for today, Professor Grace Oluwasnoya. For those joining us for the very first time, we say welcome to you. We are glad you can join us today. Thank you very much. The UNU-INWEH Science Talk series highlights the diverse, policy relevant and interdisciplinary work of UNU-INWEH and our global network of partners and experts. These sessions are designed not only to share cutting-edge research, but also to demonstrate how science can inform policy, drive innovation, and contribute to real-world solutions for pressing water, environment, and health challenges worldwide. So that's why we're here. Before introducing our distinguished speaker for today, I would like to note that, as always, today's session will conclude with an interactive Q&A. So we encourage you to submit your questions in the chat at any time during the presentation. And we will address as many of those comments or questions as possible at the end of the session. Also note that today's science talk is being recorded. The recording will be made publicly available after the event. You can find recordings of all previous science talks on demand through our website and YouTube channel at unu.edu/INWEH/science-talks ending with an S. The topic of today's talk is land cover mapping in the Hindu Kush Himalaya, lessons for climate resilience, ecosystem management, and sustainable development. So let's talk. Our presenter is Mr. Kabir Uddin. I hope I got the pronunciation right. Mr. Uddin is a geospatial specialist with extensive expertise in GIS and remote sensing. He applies Earth observation technologies and advanced spatial analytics to generate policy-relevant insights, geospatial information services, and decision support tools that help governments and development partners address environmental challenges and strengthen community resilience. Prior to joining us at UNU-INWEH, he has worked as a GIS and remote sensing at the International Center for Integrated Mountain Development, acronym ICMO, leading and supporting regional geospatial initiatives across the Hindu Kush Himalaya. So he will be sharing insights, from all his experiences, here today. He's also a research fellow, geospatial analytics for disasters and ecosystems here at UNU-INWEH. So I present to you Mr. Kabir Uddin. So Kabir, the floor is yours. Thank you.
Thank you so much for giving the background and introducing me. Welcome to my science talk on land cover mapping in the Hindu Kush Himalaya. Before starting my presentation, I want to thank to my previous organization, ICMO. Also, this majority work carried under the survey SKS. So I acknowledge. Also, later if I have more chance to, I will acknowledge more. So normal questions is come when we do presentation, land cover and land use. So these are the work as a part of the remote sensing. We use as a land cover as a one of the mapping components. So land cover is a physical materials of surface. So land cover quantify like grass, built-up area, trees. Those are the area most common. But we did not focus on the land use. Suppose some area is the protected area or commercial use or institutional use. Such kind of was not possible. So we remain our land cover purely classifying as a land cover or classifications. This type of land cover classification, when we do, why actually it was important? Why land cover map? So if we see lots of publication like Committee of Observation System, they published a book, they highlight very much in the how land cover mapping contribute in different area like ecosystem account or disaster support or many other way they highlight it. Those are the area or water counts. Those are the things. So who are here, most of the you also know how is that land cover very much important on that. So our focus was the land cover mapping in the Hindu Kush Himalaya. Hindu Kush Himalaya in this map maybe not very much clear what is the happening, but this is the very large area maps are there. So it started from the Myanmar and another part of the Hindu Kush Himalaya is Afghanistan. Is 8 countries. It has lots of major river basin are there. Lots of transboundary landscape are there. And Hindu Kush Himalaya, one of the great contribution is control the climate regulations. Climate regulations is providing the ecosystem services downstream, upstream people. Lots of people are benefiting on that. But if we see over time in this Hindu Kush Himalaya, due to the population pressures, even some natural process, land cover are changing. It's sometimes maybe a demand from the people. So when we started the work, why not use, okay, land cover very much important for Hindu Kush Himalaya, why not use the land cover mapping of what we are the existing? There was, yes, definitely lots of land cover ongoing work was doing. So you can see those are the land cover maps are available. But at different time, actually, different kind of land cover classification scheme used. Also, different satellite data used, harmonized land cover classification was what is the needed for Hindu Kush Himalaya was not there. So therefore, one of the main challenges was there to quantify the changes over time, whole Hindu Kush Himalaya. Also, we are expecting to have a land cover is annual basis. One of the example like a modest land cover, one of the very much frequent land cover we can see. As we are talking about football World Cup going, one modest pixel, how many stadium? So if you count as a modest pixel as a 250-meter resolutions, then you will see the 1 pixel equal to 12 football fields. So does it actually useful to change and anywhere does it change the 1 pixel amount land cover? Suppose forest lost 1 pixel, that's mean 12 play field has lost. So therefore we saw that this type of like coarse resolution image also not that much perfect for our area. Besides that also when we are staying somewhere else, like hardly we can see that there is some changes are there. This is the pictures I captured twice in Myanmar, one of capital city, which is over time how was changes. Just see the this is the sometimes it's positively gaining like a greening area you see the most recent, but when they started the capital uh, scenario was like this. If you go more recent, you will say, oh, this is the more green and everything. But when they started capital, it was like that. Same thing, these are the two pictures I captured from Isimot building on top of that 2009 and 2019. So 10 years interval, if you see that window are blinking with the round shapes, those are the building are same. Background was the terrace agricultural land, but over time those are that taken the building. And if you see the buildings, not only buildings, there is hardly you can see the proper connectivity, accessibility are there. So, but these are the demand. Maybe people need to do residence. But if you go Isimod, my previous organization, you will see that okay, maybe city was like that. So that's why we thought okay, land cover can give some good evidence. Does it okay? You have seen some city in the like Myanmar capital, Kathmandu. Now this is the photo I captured from the Bhutan. So Bhutan also there is sometime maybe forest changing. Though we know Buddhas are the very they are well maintaining some forest and everything, but due to the some time of some construction, like this is university was constructing, there is also some changes are forest cover. So those type of changes are happening in front of eye or maybe bit far away. But Hindu Kush Himalaya very large area. Can we quantify by a human eyes? I think sometimes very not it's not possible. So therefore we need to depend on the satellite images. The which one can go back end. Also it give regularly land cover mapping. So understanding those are the need actually land cover over time changing in front of eyes or very far area. So under the survey Hindu Kush Himalaya in present of all the leaders like forest department who are the key stakeholder and other agency together, we had a lot good meeting together. We came up very consultation workshop that how land cover mapping will be different, generated, like what kind of land cover classification system will be used, who will be using, how will be useful. Those are the things. Besides that, we had a partnership established, like you can see over there, Dr. Mir also, who is sitting in the dais, he was also part of the process. This and other definitely other survey colleagues who are the key contributor in US Forest Service and Survey Global was also key contributor on this good achievement. So after all the consultation, everything we have come up. This is the main steps we followed. So we use the Landsat imagery, we use the machine learning, and we have used the decision support tree for final land cover. So this is the steps you can see land cover. But in this land cover process, we have a series of interaction, field work, data collection, and everything was involved. I'll go in detail in this process. So satellite image and tools. Satellite image, there is lots of satellite images are available, publicly available. So our intention was there, we use the publicly available satellite images. So if these are the system our government are adopt, then they not need to buy satellite images on that. So we found, okay, what kind of satellite data we can use? Definitely Sentinel-2 images are the more better resolution, 10-meter resolution. But what Landsat image has a long archive. So it started backend um, long. So in this war, our consulting with our stakeholders, they thought that if we can have a land cover map like 2002 onwards, that is giving more consistent land cover at 30-meter resolution, free of cost, and it has a also good spectral bands. Altogether, it was decided to use the Landsat all bands like 5, 7, 8, 9. So those are the we have used for this. And another option there, we are doing land cover mapping classification. Several kind of techniques previously we had experience, good experience, like knowledge-based classification, object-based image classification. We had got the very good result. But later, what we found, okay, this Hindu Kush Himalaya, very large area, how we can handle such kind of data like pre-processing, having a good composite, all others. So Google was kind of enough also, they support on that, our providing the large number of space for processing on that. So all kind of processing we have done the Google Earth Engine as a platform. It was so easy for us to do all the procedure are there. So our main tools input image was Landsat image with other layers like OpenStreet data. We had actually, when we were doing the land cover mapping, built-up area and barren area was mixed up. So we produced one indices So based on that, we are able to separate the built-up area and other barren area, which are spectral similarity very high are there. Sometimes even traditional mapping, we could see there is a riverbed, middle of the river, no vegetation area mixed up with the built-up area. So those are the procedure we use. Also, DM and other indices we have used. And in this, the Landsat image altogether, we have. Oh, sorry. Yeah. This is the finally processing that. This is the Landsat composite we can see using the Google Earth image. We can you can see it's a very nice composite what was finally used using the Google Earth engine. And once we have a composite, we attempted to collect the land cover training sample, which was later is used in the machine learning procedure. But if you see the one of the field photo we had in the from the Mustang, those are the very rough terrain are there. So using the traditional FAO developed land cover classification system, the form, it was not very much easy to collect on the field-based information each and every places. But but similar data for how we can collect. So later FAO developed one of the tools is called collector open forest. So we have used this collector tools for initially data collection of whole Hindu Kush Himalaya. But later, one more like systematic reference data collection tools was developed for the survey collaborative effort. So we have created systematic grid for whole Hindu Kush Himalaya. We have collected around whole Hindu Kush Himalaya 51,000 reference point for Hindu Kush Himalaya. So this is the also tools anyone if you want to collecting the land cover reference point is good because is very good in this sense. If we go to the field, we can collect the present situation, but how is the past situation was there? What was the previous forest cover, or that river has changed to the now, or those are the change. This systematic approach collected giving that through the lots of satellite images indices are there. Based on we can also generate our plot size, everything so easily. So we have used the collectors online and we collected the data. Beside that, also we have been field. We developed the land cover using the history tool survey 1, 2, 3. We develop also apps. So within the like stakeholder like Nepal Forest Research Training Center, Bangladesh Forest Department, or other country together, we have also together to collect some more additional field-based point. So this is just quickly log. This is the point, like you can see the satellite image and trees in the middle and paddy land. How does it look? Same thing here. You can see there is the forest land in the middle, in the grassland are there. And the similar way, you can see the very nicely planted rubber plantations in this. It has a very in the high resolution image. How does it look? The rubber plantation on the photos. So those are the information collected. We have collected. So this is a whole Hindu Kush Himalaya. You can see the training sample how is being distributed when we did map. So this is one of the very important important input for us to train the model. So here I am coming to the like as an example from the Nepal. So because Nepal, why I'm using because within the Hindu Kush Himalaya, Nepal also one of the entire countries, and Nepal government also being used similar approach so with their need on that. So I'm just narrow down on that. So similar Nepal was 36,000 sample point was collected, and using the random forest machine learning, we had this approach as a primitive approach. So using the training samples, satellite images, and many indices we have used, we use terms as a covariate. We produce the like tree primitive. So we gas primitive, snow primitive, water primitive, and this is the probability layer. Based on that, we put in the decision support tree. Suppose the tree height maybe 5 meters, a tree canopy cover, and also tree probability. All together, we come up with the forest layer. In this process, also I acknowledge University of Maryland. Their team also produced the tree canopy cover, canopy height, annual basis in this process for us. So those other things also technology transferred at ISIMOD. So we had all the parameters need for proper way to classify the uh, like a land cover map. So this is the if you see in the below how is the decision support tools we have used in this process, you can see. And finally we have decided to the comma particular classes. So if it decision making, okay, if it condition field, then move to that particular classes, and other primitive layer move to the not that particular classes. So considering those the training sample primitive approach, finally we produce the land cover map for Hindu Kush Himalaya. This is the more comprehensive land cover till now for like annual 2000 to 2023 we have completed. So land cover map. So now survey collaborative, it will take further to go to that. There is a little bit gap 2024-25. So I hope soon it will be also come up there. So this is the land cover maps you can see, and also it has a these data publicly available. Anyone wants to download from the ISIMOD website. It's called Regional Database Management database system. Anyone can download this data, they can use. And also scientific details, I'll give little more details how we ensure the quality assurance. As I mentioned, the land cover data, we mentioned our stakeholder. Yes, the stakeholder was very much important because we develop land cover data. Sometimes we limited us in the scientific experiment, but this was data beyond the scientific experience. This data, it was launched on Earth Day. First data was launched Nepal government officially. Uh, uh, Officially, then these are the system as it's a continuation going on. So Nepal government uh, using the same way, they are also producing land cover map, and they are publishing this report. One of the great things happened in Nepal land based on this land cover. They could see also that there is some gain in the Nepal forest cover, and finally, nearly $9 million, they got also financial incentive based on that because they are protecting forest cover very well. So this is kind of very assessment and there. And these are the system also Nepal and Kabari, their website, government website. Data can be downloaded also on the beside the ISIMOD survey global website. This data can be downloaded also from their site. Report actually completely published by government as and also Nepal Statistic Department also reporting based on this work. What we have supported. Similar way, using the same approach, special land cover map for 30-meter resolution, it was produced for whole Afghanistan. It was there is procedure actually we maintain. We have a pre-launch, we have a final launch of land cover. Pre-launch was done, but later changes in the scenario. We cannot make a full government could not fully because we are disconnected with them at the moment. We could not continue. So this data has been also published. Data has been shared to the RDS folder of ISIMOD. Anyone can download this data. So this was also annual land cover. Similar way, we have worked Bangladesh Forest Department. Bangladesh Department, we had a training with them. We had a field work. We produced the land cover, but later they had a good fund, so they could buy the high resolution image like commercial image. So they produced the land cover to their own method. One area we could not actually success because they have a high resolution image. they produce land cover, but that land cover not annual basis. So 5 or 10 years interval they are producing the land cover. But our advocacy was how Bangladesh can be benefited to the free or public level of satellite image other than buying the expensive satellite image. So this was the procedure for that. So when we do land cover mapping, yes, there is quality assurance is the very much important until we produce the land cover map. Quality, validation, accuracy assessment, it doesn't work. So one of the procedure was we have a pre-launch, as I mentioned before. We had a pre-launch this land cover. We have developed customized apps. So we have anyone visit the website. Or once they have visited the website, they can actually view the land cover. They can see overlap with some satellite image. They can also other information. So they can actually make the comments on that. Okay, particular area land cover is not accurately mapped. They can make a comment. So we keep this information for a few more months. Besides that, we had a technical committee actually. Suppose Nepal, when it was published, you can see the picture is the freelance workshop. People are viewing this land cover data and they are giving their comments. Besides that, there is a formal technical committee was like academician, government agency, also key others agency who will be using the land cover there or the part. Finally, this all the formalities was maintained and land cover was officially approved as a government product. Similarly, if you see the land cover products for validation process, we have been even Afghanistan to collect the land cover reference point in Kabul University. You see the somebody collecting the reference point using the collectors online. Yes, so we had still we had some key concern on that land cover mapping. If you say banana is a 10 months crops, sometimes it gives the spectral tone with other forest or Nepal government has a one of the class is called other wooded land. Also, sometimes plantation you can see the eucalyptus one of the plantation are there. So plantation also sometimes there is a massive rotation out there. They harvest those trees and again they plant. So we have been such area to verify on that. And another kind of plants is Mycenia is remain also very much green. Sometimes it's a confusion with the grassland or cropland or others. So we have collected as much a reference point. So Nepal government also consulted with the stakeholder. We are part of that process of that, and they also get the more feedback on that. When we are also collecting this land cover data, collected online, you see the image particular date. If we change the image like snow reference point we are collecting, so you see that white area is the snow. If we collecting the same year like 2018 January, as there is no, hardly snow out there, but same year 2012, if we collecting the reference point, we make collect the snow. So in this area, as we produce the like annual composite, so those are the area we minimize the issues. Similar way, when we are collecting the reference point from the rivers, river course same year or sometime are changing is there. So it's a very dynamic river like Koshitopo, Kushi rivers are there. So we have to collect carefully all the reference point. Otherwise, due to the just month changes are there, it can give the misleading reference point while we are using in the machine learning algorithm. And one of the confusion was the other wooded land. This is kind of forest, but it's mixed up with some other grassland, tree. Also, some issue with the but Nepal government they wants to maintain the other wooded land. but it's not that much high trees and everything. So there was some key concern. Beside that, very much the cast shadow in the mountain area we had all the topographic collection, image collection procedure we have followed uh, in these regards. So finally, you can see the land cover maps of what was produced for validation. I mentioned, and this is the reference point was used for the validation point. We are thanks to also Kathmandu University, who student also they supported the collecting validation point in this process. They were the intern, and many are now though they are good professional. They are working professionally. US, Nepal government, many other here. And accuracy, you see, if you see Nepal land cover maps, 84% for 2019 and 2018, almost similar. Kappa statistic 0.73. But one good things happen when we merge the land cover in the IPCC. As we mentioned, that this classification scheme was adopted through the LCC. FAO developed the land cover classification scheme. So it can be merged this land cover data into the IPCC classes, because Nepal government or any other government, they need to report this data to the IPCC report. So there is specific classes are there. Once we merge those class to the IPCC classes, then accuracy is increased 89%. So this is the where we control similar way. Actually, Hindu Kush Himalaya land cover produced what that was the 81% our accuracy for Hindu Kush Himalaya. So when we are doing such kind of land cover, was there some changes we could observe from the land cover? If we could directly show you land cover maps from the images, other than give the few impression, I'm showing some window here. Just quickly see how Nepal has gained the forest. Here is you just see the riverbed, and slowly you see how in the river area also some new trees taken over. Similarly, it doesn't in every hour they gain the forest, but there is also chances are there. Forest may be forested area appearing as a new settlements. Same thing, new settlement coming. But if you see the right images there, you get the surprise how people are coming to the occupying the riverbed, and they are doing the settlement on the river exactly. But we don't know if when a massive flood or heavy rain will be there, they may get seriously impacted. So we could see such kind of changes over there through the land cover, and this is the from the high resolution image we could see show you some weakness out there. So this land cover, as we mentioned, we procedure all the detailed steps are needed for scientific validation, stakeholder engagement, use the robots methods, everything were there. So all the papers, actually scientific paper also we have published um, uh, different kind of journals as evidence on that. Particularly this book was leading by three editors, surveyed what they developed, Mr. Birendra, Dr. Rajesh Bahadur, and also in this panel today attending, Dr. Mir Matin was also one of the editor, and Dr. Mir Matin was the science and data lead as well as team leader at ICMOD that when we are getting this one. So these all the reference I'm giving to with you, and I believe there is lots of questions, concern you may raise. Though I could continue another 5 minutes more, but I'm interested to have a more interaction. So with that, I am thanking you. I'm grateful for your uh, participant and seeing my presentation. Looking forward to have more questions.
Impressive. Thank you, Kabir. Before jumping into any of the technicalities, I'm just curious. The initiative, who initiated it? Is it from the academic angle or from national government, or it's more just being ICMOD? You know, that's one aspect of it. The second aspect is the major funding for it, because it's quite huge. Who funded it?
This land cover mapping work, actually, we are doing ICMOD previously. ICMOD has a very strong capacity on the remote sensing work. But these are the work funded by USAID, NASA funded project. It's called Survey Hindu Kush Himalaya. So there is survey collaborative process. So here, as funding scenario has changed recently, that's why I mentioned only on the survey Hindu Kush Himalaya. I did not go to the like donor specific example are there. Definitely, it's a huge contribution from the USAID and NASA. And they provided also technical support beside that also as a grant to ICMOD. And this was the great contribution. And we can consider this is as one of the successful story, because this was the beyond the um, development of the land cover data, because data being used by government for their regular purpose.
You know, I because I know HKM is often described as the freshwater tower of Asia. You know, and now you're saying NASA sponsored it. So I'm just curious. You know, we have, you know, impressive or very big watersheds in Africa, for instance, like the Congo River Basin. So is it possible to extend that kind of hand of friendship that NASA also could fund, this level of land cover monitoring in the Congo River Basin? Because Congo River Basin is the second largest after Amazon. So it's quite huge. You know, what's your take on that?
Little bit actually noise was there. I could not get, but yes, these are the contribution was very much important for our region, Hindu Kush Himalaya. And people actually, if you see data use wise, it's very massive. Beside the government, it's highly downloaded data from ICMOD RDS. It has one of the paper we published. It has like more than 400 citation. Only one
The question
paper.
was, you didn't hear the question well. Maybe you can write. Do you see the question chat?
I have to.
The question was whether this kind of project can be implemented in Africa region, Congo basin.
Okay. Yeah. Sorry, I could not actually get. Yes, this is the one of the scaling opportunity. This is the complete, all the code are public. So anyone can download, they can use actually. It can be replicable, similar methods is any hard part of the world. So this is code available, applicable, because we are using a publicly available data. It's not, we are like Lancet free. So if other part of the African region they wants to use, they can use also land covered same Lancet data. And same, but definitely they have to collect additionally the training and reference point. And this and tools like collector online, it's completely free. That also was developed USAID and NASA funded, same survey collaborative. So data can be downloaded, Google Earth Engine can be use.
I'm still not satisfied with the answer because I know that this can be replicated, but it involves a lot of, the funding behind this is quite huge. And USA is not, Hindu, it's not Asia. So we know the difference. So my question is, understanding the process that can make, for instance, NASA to implement this level of work in a region like Africa?
There are some level of staff, maintaining staff will be required, I believe, but not huge funding will be required. Some same organization like Nepal government, forest department, they are maintaining their staff. They are actually, once we have a capacity being built, they can do themselves. Some capacity building, if, now ICMOD are not producing for land cover for Nepal governments. Themselves they are producing.
Okay. Where do you think the biggest changes are? I know you showed us in some of the slides where the changes are taking place, but where do you think the biggest changes are in the HKH?
Bigger changes happen like in the city are changes rapidly. If you see Kathmandu city or any other city are changing rapidly. Agriculture land occupied by settlement. So this is the biggest changes are there. I think built up area over time in as an example, I can tell Nepal. Nepal forest remain increased, but beside that, agricultural land converted to the built-up area, settlement area. So this is the major changes, and those are the city so far. I believe not proper planning approach are adopted. So if it not proper planning approach adopted, sometime people may impact upcoming disaster are there. Even Kathmandu flood, more recent 2024 flood, if you see, that was the one of the good signal. Thame flood, Nepal good signal. So data should be used, I believe, and understanding the change. So city, one of the major changes happen.
Before I open it to the floor, because I know others are itching to ask questions too. Let me ask this. We can tell the interconnections between all the different land covers, water, urban sprawling and the like. So then, of course, the influence of climate resilience, well-being, all those are interconnected. So I'm just curious, how can land cover monitoring systems be better integrated, for effective international development or at least sustainable development?
As you mentioned, interconnection. So first of all, if we say land cover metrics we produce, so over time land cover transition one class to another, but we have produced on that. But beside that, we can see the land cover data, what we produce, inter-agency they have used. So these data not only for Department of Irrigation, they use this land cover. Though our main stakeholder was the forest department. Other agency, when they are reporting, suppose when some flood happening, that time they are trying to get the, okay, where is the major damage area, like what kind of agriculture land are impacted. So these are the interagency also working or benefited on that.
Okay, we have question from the floor. Dr. Abraham.
Okay, thank you, Kabir, for the insightful presentation. And I think in your introductory slides, it showed that HK pass across different countries. And my first question is, are you able to communicate your findings to the actors involved? And if you do, what are some of the conflicts that are arising? For example, conservation versus development, national government interest versus local government.
As a ICMOD as an intergovernmental apolitical organization, we don't have scientific achievement, we don't have any issues to share on everything. But when 8 countries, if we tell these 8 countries organizations, so 8 countries, if you see these maps, we have not used any boundaries. It was not used any boundaries because boundary, there is some country to country has some conflict boundary. That was. But findings was actually very much useful, but it did not create any conflict like, okay, uh, it did not like one country to another. So it was not like that. Other than in the regional land cover mapping workshop, many of the countries, they were present together and they are appreciated very much.
All right. Sure, we heard you right, but we'll move on. I just want to know, in doing this, because I know it took some time, about a decade and all the like. What was the biggest challenge? One or two, challenges, maybe one or two that you can share with us.
Biggest challenge was, I'll say, because this USA NASA survey was user engagement. Suppose data what we are producing, data has to use by government as a government product. So this was the one of the aim. So Nepal we succeed. We could scientifically we can convince they are part of that. They are very happy to use this one. So this is one kind of assessment for Nepal. But if you say other countries like Bangladesh, we are completely failed. This data was not adopted by Bangladesh government because they have a money. They had a money, so they could buy a high resolution satellite image, commercial satellite image. We did lots of advocacy that okay, the free satellite image can be better. You enhance your skill. Your staff should enhance their skill. They should ability to produce this land cover map themselves, other than depending with us. So that was the main challenge on that. Still challenges are remaining because in artist remote, if they're working such kind of things, they may sometimes actually main challenge is that money is the problem. When you have a money, then you buy the high resolution image, commercial image for one time. But people are not too much interested to build the capacity for future. So that is the one of the sustainability issue I found in Bangladesh. Where is the Nepal government same system adopted and they achieve the financial grant.
Okay, I'm just thinking. Let's consider this scenario. Land cover monitoring, political instability, and corruption. Where will you place in terms of priority if you happens to be the president of a nation, being faced with, yes, climate changes, now I guess there's the current wildfire going on in Canada right now, then land cover monitoring, political instability, so how do you juxtapose this? What will you be what be your priority, in resolving these concurrent or events happening simultaneously?
Here, I'll not go in depth in the political side, but one of the political statement is produced from the forest. Suppose each of the country, they give the statement, we do have a forest, this person. Like Nepal government, proudly they sell, they had a forest cover like 44%. From there now, they have a 46% forest. So these are the very, very political, not only political statement, this is the authentic statement they are able to see from the land cover. So if that country don't have 46% forest, they have a 30% forest, but they want to say this are the 46%. These land cover data can give proper evidence. Okay, you are telling this mass forest if data is public. We have to make a data also public, because until we make a data public, giving only JPG maps is not enough. So it can be, if somebody hiding, they are not producing the accurate forest cover, it can give the right information, I believe. So, but beside that, political stability, I'm not able to talk at all.
I'm just wondering, with this increasing use of AI and machine learning and all that, how do you balance that with accuracy, transparency, and trust among users?
Yes, these are the tools day by day improving. It's enhancing the quality on that. So machine learning, GUI now more accurate information giving. So definitely it's enhancing the transparency, accuracy, and everything. Based on that, it's going to be a more productive, useful data. And government has to intend to adopt such kind of upcoming technology. What is there? Dr. Mir, you are trying to say?
Okay, we have a question from someone, Ram Parajuli. The first part of the question is, what major challenges do you foresee in Nepal from your topic or from your perspective?
Nepal actually, during the survey first phase, we developed land cover 2010 land cover. So we are not actually together that time. It was a DFRS name. Now it's FRTC. It's renamed to the FRTC. That a government agency, they are involved in the for mapping, such kind of forest mapping. So we did mapping. Then later, when we together we want to go, it was not easy to adopt them then. So that was the one of the learning for us, that if we are not together, we are working, they doesn't like the data, they are not trusted on the data. So service second phase, when we have, then we started to collaborating with that. We engaged so much with them. We have done field work, joint workshop, and also we have built the partnership, signing the MO, and that's how we overcome the challenge. Nepal government was very very much positive on that. I can tell Mr. Deepak Kharal to like M. Pokhrel and all the now present secretary who are there. Everybody was so cooperative. Even all the officers at FRTC, they are very. We have not faced any challenges. Even when I was actually moving, they were a bit worried. Say, oh, if there is any technical support needed during the land cover mapping, will they get or not? Nepal government is very positive on this map. We have not faced any challenges.
Okay, we have another question here. Someone is also asking,
Simon.
Sorry, would you please? Okay.
I'm trying to read.
Okay. Whether a project can be applied in Congo Basin? Yes, this project can be used other basin. So we can customize with changing the boundaries. Similar approach can be done.
Okay, someone is asking, I would like to know whether the current HKH land cover mapping system can distinguish different types of aquatic vegetation, or whether wetlands and open water areas are currently grouped into broader categories. That's a very smart one. Is there any possibility of incorporating invasive floating plants, such as water hyacinth, as a separate land cover class in future mapping efforts?
First of all, if you say water hyacinth, I'm from village from Bangladesh, so I know water hyacinth. How does it move? How move. This is whole Hindu Kush Himalaya practically. Another 10 to 15 years almost impossible to mapping annual basis, or is a water hyacinth today somewhere, but within a month, within 2 months, it will move somewhere else. So water hyacinth, top of the water, that wetland vegetations, not that much easy. And our ambition was not to go that much deep, detail now. It was what is the needed for the broader land cover, consistent land cover, that one. But additional land cover, suppose Nepal government now have adopted another work is the major forest types. It has produced, that is also Nepal government published. That is the major among the this land cover. You have seen these two classes, forest and other wooded land. But within the forest, we have produced the uh, like 26 classes forest types maps. So that is the purpose was their World Bank funded project that will contribute the municipal level revenue sharing. So this is mode also contribution to the World Bank fund project to the Nepal government. But those are the work can be done. Some other invasive species like Bhutan. Recently, I was working the rangeland map. Or is the invasive species taking over the? But that we should not mix up this work and that work. So new work should be done because our ambition is same consistent classification scheme, produce the land cover map annually. So new work can be produced, but it should not be mixed up with the suddenly 20 classes like that.
Okay, I have another question here. How did you distinguish built-up areas from bare land, given their similar spectral signatures in Afghanistan's arid landscapes?
Yeah, that was the huge challenge for us. So, like Lance's spectral characters was not easy to bear area. To that, we have a challenges. Even machine learning, even other hardcore like machine learning algorithm like TensorFlow and everything. It was what we did. We developed using the OpenStreet data. OpenStreet data has a building, road, all the layers are there. But that is the most recent year. What is the 2022? It has also very much relation with the changes in the greenness. So we develop one of the indices build up area matrix. We have published that paper in the MDPI remote sensing, how build up area can be mapped actually using the OpenStreet. So those are the primitive we integrated in that. Then we perfectly overcome the challenge. And another normal traditional mapping, what they feel, build up area is the build up area always increasing our area. Building area not decreasing. But if you traditional mapping, you see the even other land covered globally available, like 10-meter resolution available. You will see the sometime Kathmandu build-up area may be increase, sometime decrease because of those are the consistent approach they have done. But our one build-up area gradually increasing and all the things. But we use the new indices ourselves. We develop combination with the NDVI and OpenStreet data.
Thank you. Maybe one last question before our time runs out. So what's the next step now?
Next step, still there is huge demand. This data will be continue. For the time being, government wants to, at particular Nepal government, same system should be continue. That is their demand. But next step, definitely, these are the improvement can be done from the like maybe 2022, like 10-meter resolution image can be done with like demand from invasive species in the high resolution image, high mountain area, range area can be mapped. Those are the area. Also, more classification, more types of wetland can be mapped. That might be useful. But I'm not part of now anymore ISIMOD. So I left. My last working days was at ISIMOD 24th of May.
All right. Thank you very much, Mr. Kabir, for such a thought-provoking and inspiring talk. We really enjoyed it. And thanks to everyone for the engaging discussion. I guess this is the time to give us.
Thank you so much giving me opportunity. I thanks to our formal team leader and science center lead, Dr. Mir, also in this opportunity particularly. And thanks to Survey Global, NASA definitely still, was a part of this, and also ISIMOD colleague who are contributing this work. I'm thanks to everyone. Thanks to United Nations University, particularly all of you listening me and giving me chance. Thank you.
All right, thank you. This brings us to the end of today's UNU-INWEH Science Talk. If you enjoyed the session, remember that all our previous talks are available on our website and YouTube channel, again at unu.edu/inwe/science-talks, ending with an N. Please feel free to revisit or share them with your colleagues and network. We'll be back next week with another exciting presentation exploring, of course, new ideas at the intersection of water, environment, and health. Thank you all for joining us today. We look forward to seeing you next week at the next Science Talk. Have a wonderful day. Bye.